Hello students, in the previous lectures we have discussed how to find limit of a vector point function, discuss the continuity of vector point function, then find the differential of vector point function of one variable. Now we will continue the process to find the partial derivative of a vector point function. This is the formulae or the basic concept is the same as we have discussed in the differential calculus, the partial derivative of scalar point function. The formulae are same as discussed in the differential calculus, plus 2 as well as plus 1 plus 2 as well as first year, and only the concept of direction will be taken care of while finding the partial derivative of vector point function or the scale point function. Basic concept is same. So let's generalize the derivative of function variable to the derivative variable of several function. Number of individuals can be more than 2, 3, 4, or any number of variables, which we are generalizing the derivative of a function for more than one variable. So definition of partial derivative is, let this R is function of is a vector function of position vector of any point in three-dimensional space. R vector this is a position vector of the point P, any point P of the three-dimensional space, particle on, along which the particle is moving. Then the partial derivative of R with respect to, now this position vector have three independent variables. Now if we'll if we remove just y and z from this, then R become function of one variable, means the motion will belong the one direction. Now if we remove z from here, the motion z is a function of x and y, means the motion of particle or the any insect is on the plane. Plane means on the wall of the house, wall of the house, or the blackboard, or on the face of blackboard. And if R is a function of x, y, and z, three variables, independent variables, then the particle or insect is moving in or flying, or the body is flying in the space. So partial derivative of R is curly R upon curly x. This is partial derivative R is to x. So in place of ddx will write partial derivative. So this is equal to limit. Now x, where differential is to x, the change will be on x. Change will be in the x component only. So this is the limit delta x of 0 f vector of a vector partial derivative R vector is to x is equal to limit delta x is 0 of f vector of x plus delta x, y and z remains same, minus f vector of x y z upon delta x. Now if we just remove, now this is, we can convert this into the ordinary differential of y with to x. If we remove y and z from here, so this will become, what does this become? This become ddx of R vector, which you have studied a few lectures back. This could limit delta x of 0 of f of x plus delta x minus f of x upon delta x. This is a R is function variable. Now function of two or three variable, with this the and the change will be in the variable with respect to which we are differentiating the position of a point. This is, now if we want to find the partial derivative for R is to y, then this will be limit delta to 0 f vector of x y plus delta y z minus f vector of x y z upon delta. Similarly, we can find derivatives to z and so on, any number of if R is function of more than three variables, we can, this is generalization of the definition of the derivative partial derivative function. So we can find this to R equals to y and R equals to z, and similarly now I told you how to find these vectors. I'll take the point. Similarly, we can find the higher order derivative also. In order to find this, we will differentiate push to R vector with this to with respect to x, we find positive derivative r equals to x. We will differentiate this with x and treating other variables y and z as constants. So, in order to use the formula, we'll repeat this process, and the formula is same as discussed in plus 2 and first year. Similarly, we can find partial values to y and partial to z if we're differentiating our position point which is to r y, then we'll treat y is independent variable and x is x and z are constants. Similarly, x and z we can find. The similar process is followed if number of independent variable are more than 3. So this generalization of definition of the differential of a differential of a vector point position vector point is to any variable. Partial derivative in component form. So if R is in component form, x component, y component, z component, the partial derivative R is equal to derivative first component. If we apply the product here, product for this is constant. Constant will be taken, will be relative constant is itself is 0. So if you apply product of this derivative of x is to x and this is independent of x, so this will be 0, and similarly we will get partial x component iota, partial y component j, partial z component k. So the chain rule, if r position of point is a function of x and y variable, and x and y function of variable t, then differential of r equals to t will be equal to r function x and y. Also r is to x dx dt, also r is to y dy dt. So higher order derivative of vector point function can be calculated in this similar fashion. You can find third order, fourth order, and any order derivative. So total derivative. If we remove just delta t from here, total derivative, this will become delta t from here, delta t, this will total derivative r is to x and y. Now, in case of total derivative of r is to x and y, we are not given x and y a function of t. So this is to get the total derivative. Now, similarly, we can find derivative. Now, let us use the concept which we have studied just now. And if f is a function of x y z, is given x component is this, y component is this, z component is this. So then find the partial derivative of f equals to x, partial to y, partial to z, second equals to x, second equals to y, and so on. And also show that now when will be the equal partial of f is to y, then x, then x, then y, they're equal if f has second order constant derivative. Now let's calculate. Now f is 2xy, 2xy, x of 4 iota is the xy minus y sine xj x square cos of y 30j. So definition is to x. So x definition x component is x, definition y component is x. X component is x will be equal to how much? How much this will be equal to? Now we are definition is to x, y is constant, 2y is constant. Differential of x will be equal to 2x. 2x minus, now x is equal to 4x cube iota plus differential of e to xy. Is the xy is equal to a square xy, differential xy is equal to y, xy is equal to y is power xy minus differential x, y is constant, minus y dx of cos, sin is equal to cos of x j plus this will be equal to plus how much? Plus this will be equal to partial to x, cos of y constant, x is x, this is equal to cos of y k. Now second derivative of this, this will equal to 4xy. Simplify 4xy, differentiate with this with x. Again, this is constant, 4 is constant, this is 4y, and this is equal to, now with differentiative is to x. This is equal to minus 12 x square iota Now differentiate this with to x. Similarly, differentiate this with to x is equal to y constant e is power xy because e is to xy and coefficient this differential this xy is equal to y. This is y square e is power xy minus it is to x is equal to minus plus cos y cos of x into g vector and differential to x will be equal to g vector. Similarly, now second row to x. Now if we differentiate this with x is to y, this is to y. X is to f of x first is to y. How much this will be equal to y? This is equal to 4x. 4x is equal to constant 0. 4x iota. Now difference to y. Y is equal to product will we have to apply product here. First function as it is. First function as it is. Differential of is equal to this to we are differential is to y is equal to x e raised power xy plus xy plus differential y 1 e is power xy now this is 2y is equal to minus cos of x into j differential is 2y differential is 2y is equal to minus sine of y now simplify we can simplify it also now if similarly we can simplify it and rearrange the terms different components. Similarly, if your differential is 2y, this is equal to y, differential is 2y, this is equal to 2x is constant. Now this is equal to 2x square. Now this is x square, with difference 2y, this is constant 0. 2x square iota, difference is 2y, this is equal to plus y, e square xy, same, e square x, difference xy is equal to x. X is power xy minus if it's 2y is equal to sine of x into j plus if it is 2y x is constant is equal to cos of is equal to minus sine of y into simplified it and again if you want to differentiate this is 2y again now this is constant it's constant 0 iota this is again differentiate this to y we got x square is for xy differential of x constant this xy is equal to xy ddx of xy is equal to x minus this is constant equal to j constant is 0 and this is equal to minus this is equal to x will constant we are differential to y this is equal to cos of y equal to k. Now if we differentiate this with this to y this is to x. First is to x, we want to find this. This is to x. How much is this? This is to x is equal to 4x iota and this is to x. Again, you have to apply product here plus product here. First function as it is. Derivative is equal to which is to x. Y is for xy. Y is to xy plus e is for xy minus ddx of which to x minus cos of x j and this is equal to which to x is equal to minus 2x sine of y into k. Now if this derivative 4x and this and this comes out to be same. Yeah, same. So partial which to x and y, which to y then x and partial which to first x and y they comes out to be the same. If the function after derivative the function f of xy, left point function is as second order derivative corresponding second order derivative, and this is 4, this is 2. Now let's calculate another example. Another example is so another example is if this is a scalar point function and this vector point function, this scalar point function, this vector point function, then show that uh, third derivative of f at this. First we have to find the phi to f. First we have to find uh, phi into f of f vector is equal to, we multiply this with this, is equal to the scalar. This comes out to x square, y square, z square, iota, x square, y cube, z j plus, sorry, minus 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 x square minus is equal to x square y cube zj plus x y cube z cube k. Now we differentiate first with to y this to z. First find differential of phi of f vector with this to z, that is equal to 5. Z is equal to how much? This differential to z. How much is this? This is constant, this is constant. This is x square, y square, 2z iota minus this to z is equal to x square, y cube, this is z is equal to 1, j plus x, y cube, 3z square into k. Now, then we differentiate to x twice. This is x is to twice at the point 1 minus 2 of the equation. Now differentiate this, differentiate with this 2x of partial derivative 2z of phi of f vector. F vector is equal to how much this? Is to x. This is equal to their constants. This is equal to 4x y square z iota minus 2x y cube j. These are constants. Is equal to this 2x 3 plus 3 y cube z square k. Now again differentiate this with 2x. You have to find second order. This will become third order partial derivative of phi. This becomes second order. This becomes second order. This is this. This is 2. We can move it. We can move it from here. Second order. Third order partial derivative of phi into f vector with this to z, with this to x, then with this to x is equal to, now again the differential is to x. So 4 y square z iota minus 2 y cube j plus 0 k. Now we find the value, we are asked to find the value at minus 1, 2 is 4 iota and 2 j minus 4 iota and plus 2 j. 2 1. Now we'll find this value at 2 minus 1. This is equal to 2 minus 1 means 2 minus 1. 2 minus 1, 3 compound 3 minus 1. Let's see this. 2 minus 1. Then 2 1 minus 1 1 and 1. Second point is also there, so we have to 2 minus 1 and 1. Value at 2 minus 1 and 1 would be, and 1 is equal to 4 into x is not there, y is minus 1 square, z is 1 iota minus 2 into minus 1 square j, and this is equal to plus 0 k. So this comes out to be 4 iota minus 2 j equal to, so this is 4 iota minus, this is y cube of minus, this minus plus, this is cube. This is y cube is here, so this is equal to minus of plus. Now let's go to next problem. I'll tell you how to find them. A vector is this, B vector is this, then find the value of second quantity plus y and then this x. Again, how to solve this problem? We'll find the and find its value at x is equal to 1, 0, 2. First, we'll find the cross product of these vectors, then differentiate x is to y and then x, then substitute the value x y, replace x by 1, y by 0, and z by 1. Now, if r is equal to this, then find the partiality of r is to scalar triple product of partial r is to u, partial r is to v, partial r is to u whole. So that's fine. Let's find the partiality of r is to. Now, this, now partial derivative r is to partial r is to u. What will be the value of this? Here differential is to u is constant, is equal to half. What is the value of this? This is equal to half of a iota v is equal to 0 and iota is equal to u plus half of j v is equal to 0 and this is equal to plus half of uv v unit vector half of unit vector k half of unit vector k. Similarly, we can find partiality of this. We have find this vector, we can find this vector. Partiality of r vector is to partiality of r vector with this to v is equal to half of a iota minus half of j plus 1 by 2 of which to v u into k. Similarly, we can find partiality u is to second order partiality u r vector is to u is equal to, this is 0, this is 0, u with this 2 as u with this second order derivative, this is 0 and this is 0 plus 0 plus, so scale to product u vector, so the value comes out to be, how much is the value? Now substitute the value scale to product for the first vector, for second vector, for third vector, all the values are 0, value comes out to be value must be 0. Thank you very much.